This function is triggered by S3 when a PDF is generated. It then uses Chromium and Puppeteer to take and save a screenshot. This is one of the many ways to invoke a Lambda called triggers, which let you respond to events from other AWS services or even partner platforms like Okta and Segment. Some triggers like API Gateway wait for an immediate response in a synchronous manner and work well for request-response workflows, but not all invocations need an instant reply. Asynchronous triggers like S3 or SNS send events to Lambda and move on. These events are first sent to a queue, allowing you to configure retries, max record age, or attach a dead letter queue, DLQ in short, to handle failures. And speaking of failures, function destinations take care of handling to the next level. They can handle both success and failures by routing them to services like S3, SNS, or others. And compared to DLQs, they give you richer details like stack traces, making them a more powerful alternative. For services like DynamoDB, triggers work a bit differently. Lambda uses special resources called event source mappings to continuously pull for new events. With this, you can choose to batch, filter, and even route failed events to SQS or SNS only. But not every trigger is as complex. Function URLs are dedicated endpoints allowing you to invoke Lambdas directly. Whether public or IAM secured, they're perfect for simple on-demand workflows. With URLs, you also get access to streaming. By wrapping your handler with Streamify response, Lambda can send data incrementally, as seen in modern AI-powered applications. URLs can also be tied to aliases, which themselves are tied to versions. Each function has a latest version by default, but you can create numbered versions yourself. And with weighted aliases, you can direct traffic to different versions, which is ideal for testing updates. With so many services interacting, permissions can get tricky. Fortunately, there are just two key concepts to remember. The execution role allows your function access to other services, and resource-based policies give services like S3 permissions to invoke your Lambda. Getting your code, the deployment package, into Lambda is straightforward. The simplest way is uploading directly from your file system, but this only works for files smaller than 50 MB. For larger files or better management, uploading through S3 is generally preferred. But if you're some sort of untrusted individual, you may be bothered by how easy it is to make a mistake and upload buggy code. Well, fret not, because with code sign-in configurations, Lambda will block uploads unless they're signed by an AWS signer profile of your choice, ensuring only trusted code makes it through. And speaking of trust, or lack thereof, storing sensitive credentials is best handled with environment variables, and for even more security, you can pair them with SSM or Secrets Manager, but keep in mind that there is a 4 KB limit for total size. If you want some more storage to handle large dependencies, Lambda layers can help you keep your package size manageable. Layers will get extracted alongside your deployment package, making them perfect for usable dependencies. For instance, the Sentry layer integrates Sentry into your app without additional installations. This brings us neatly to Lambda extensions, which build on layers to interact with the login telemetry APIs. Extensions are ideal for observability tools like Sentry or Datadog, offering automatic instrumentations for your functions. But even with layers, the total unzipped size of your deployment package cannot exceed 250 megs, which can be quite limiting for cases like ML-powered apps. To handle such scenarios, Lambda supports Docker container images. Extend one of the AWS base images, build, tag, and upload your image to ECR, then use it to create a Lambda function. So far, my examples have been in Python and Node, but Lambda also supports other runtimes, as well as compiled languages like Rust and Go through the OS-only runtime. And if none of those meet your needs, you can always create a custom runtime tailored to your requirements. For Java, .NET, and Python, you can enable SnapStart, which reduces cold starts by taking a snapshot of the disk and memory and caching it to quickly retrieve it during invocations. If your function needs access to private resources in a VPC, you'll need to connect it to private subnets. So, for internet access, traffic must route through a NAT gateway to public subnets and an internet gateway. But once connected, Lambda can seamlessly interact with RDS using proxies or access persistent storage by mounting an elastic file system access point. So technically, you can actually use the FS module in Lambda. Some other configurations include setting your function's timeout, configuring temporary storage up to 10 gigs, and adjusting the memory size for optimal performance. Lambda will scale up your functions as needed, but this is bound by your account's concurrency limits. You could provision concurrency to ensure your functions are always ready to execute, though this comes at an extra cost. You might find it's easy to cause recursive invocations, so it's pretty cool that recursive loop detection is enabled by default. Finally, for monitoring, logs are automatically sent to CloudWatch, and you can enable X-ray tracing for detailed insights. These two are different beasts by their own right and deserve their own videos, but Lambda provides a built-in dashboard with high-level metrics to help you track performance and usage. These metrics come in especially handy when debugging asynchronous invocations.
I feel like a tornado in a trailer park.
Let me know if you like this video and what AWS service you'd like to see next. But that's it for now. Thanks for watching, and I'll see you in the next video.